Hello, everyone. We are here today to take a look at the Aspire to Do challenge activity for forces. So in this activity, you're going to learn how to draw free body diagrams, and that is just sort of a weird name for very simple diagrams using arrows showing the forces acting on an object. And in this case, I think all of the diagrams are going to use a square. I think there might be one exception, but this is very simple, like draw a square, draw some arrows, what forces are acting on something. So to get going here, the things that we want to remember are what are balanced forces, what are unbalanced forces, and what do they mean for the motion of objects. So balanced forces means that the net force acting on an object is zero. And that means that there is no acceleration. But remember, acceleration is only a change in motion. So there can be motion happening if the forces are balanced. It's just that there's no acceleration. So no speeding up, no slowing down, or no turning. So balanced forces mean no acceleration. That also means that the velocity is constant. Unbalanced forces are when you add them up and the net is not zero, and that means acceleration is happening. So something is speeding up or turning or slowing down. Okay, so let's do a few examples together here. So on your packet, question 1 has a box at rest on a tabletop. And you can see this very simple diagram of a tabletop and a box. And let's start by drawing the arrows, and then we'll deal with this, figuring out how to deal with these symbols on the left here. So on some of these slides, I've added some hints for you to help get you going. So as you're going through your packet, if you are struggling a little bit, come back to these slides that are linked on the instruction document to get a little bit of a hint. So if the box is at rest on the tabletop, so it's not moving, the forces at work include gravity. So gravity is always pulling on everything. So let's just start by drawing our gravity arrow. There it is. Now, because the box is not moving, we know that the forces have to be balanced. So there must be something working opposite of gravity. And we call that force the normal force, which is sort of a strange name. That's what it is. Normal force is working opposite of gravity. And if you think about it, we know this is true because if there was no normal force and only gravity was acting on this box would accelerate down into the center of the planet, right? There has to be something acting against it. And technically what's happening is that the molecules in the table are sort of pushing back. Oh, why did that zoom? That's interesting. How do I undo that? Okay, let me pause for a second and figure out how to undo that. All right, I think I got it back here. So we have our gravity arrow, and we were saying that there's something acting opposite of gravity, and we know that because otherwise the box would be accelerating down to the center of the Earth. So we call that the normal force. And we're going to draw our arrow to show it opposite of the gravity arrow, and your arrow should be the same length because there is no motion. So going back to here now, the CV means constant velocity and the CA means constant acceleration. So which is true here? There is no acceleration, right? There is a constant velocity. That velocity happens to be zero, right? But it's constant, it's not changing, it's zero, it's zero, it's zero. So that's the first choice. And then the second choice we have to make is, are these forces balanced or unbalanced? We've already said they are balanced. So that is how to fill out the first one. So now let's go to the next slide for another example. Question 2. Okay, here we go. A box being pushed to the right and is speeding up. Friction is present. So on the diagram here, same diagram, they've included a little arrow showing us which way the box is moving. So speeding up. So let's start with these choices over here. So if it's speeding up, that means there is acceleration, right? constant acceleration. And if there's acceleration, that means the forces are unbalanced. So those are the choices for this one. And over here are hints. We have gravity and normal force, just like the last one. So this box is not rising up into the air and it's not sinking down into the planet. So we can draw our equal and opposite arrows here, just like the last one. Gravity, normal. But we also have a left-right motion going on. So a box is being pushed to the right. So a force is being applied to this box. So we're going to draw an arrow pushing the box to the right, and we call that the applied force, which you can see is over here in the hints for you. I didn't leave myself a lot of room. Sorry, this is messy. Applied is going to the right. And friction is also acting on this box, but we know the box is moving. So so friction is acting opposite. So we're going to draw an arrow pointing opposite of the applied force arrow, but we need to think about how long it should be. So if I drew it exactly the same length as the applied arrow, that would indicate that those forces are cancel each other out. And there is no acceleration, but we know that's not the case. So the arrow to draw for the friction is going to be smaller than the applied force arrow because we still have motion to the right. So yes, there's friction, but our applied force is overcoming it. So there we go. I'm sorry, I'm trying. I know these are horrible. All right, let's erase that. Work your way through the rest of the packet. And as I said, if you need to come back to those slides that look like this, they do have some hints about what forces are involved. Good luck.